Assalamualaikum friends. Today we are going to study magnetic fields. When a magnet attracts a certain magnetic material, it exerts some force to do so. Similarly, when it attracts or repels a magnetic pole of another magnet, it exerts a force on it. This force can be observed up to a certain distance from the magnet that can be explained by the concept of magnetic field around the magnet. A magnetic field is the region around a magnet where another magnet object experiences a force on it. A pattern of magnetic field around a bar magnet can be seen very easily by a simple experiment. If iron fillings are sprinkled on a thin glass plate or placed over a bar magnet, the fillings become tiny magnets through magnetic induction. Now, if the glass surface is gently tapped, the fillings form a pattern. This pattern is known as magnetic field pattern. This pattern can be better shown by the lines that correspond to the path of fillings. These lines are called magnetic lines of force. Magnetic lines of force. The magnetic lines of force around a bar magnet can be drawn by using a small compass. The needle of the compass will move along the magnetic lines of force. Figure shows the magnetic lines of force around a bar magnet drawn by this method. The compass needle is symbolized by an arrow being the north pole. The magnetic field at a point has both a magnitude and a direction. The direction of magnetic field at any point in a space is the direction indicated by north pole of magnetic compass needle placed at that point. Figure also shows that field lines appear to originate from the north pole and end on the south pole. Actually, the magnetic field extends in space all around the magnet, but the figure shows the field in only one plane. Strength of magnetic field. The strength of magnetic field is proportional to the number of magnetic lines of force passing through unit area placed perpendicular to the lines. Thus, the magnetic field is stronger in regions where the field lines are relatively close together and weaker where they are far apart. For example, in figure 8.10, the lines are closest together near north and south pole, indicating that the strength of magnetic field is stronger in these regions. Away from the poles, the magnetic field becomes weaker. In case the two magnets are placed close to each other, their combined magnetic field can also be drawn by using the compass needle. Figure 8.10 and 8.11 show the patterns of combined magnetic field of two magnets lying with different orientations. Figure point X is called a neutral point because the field due to one magnet cancels out due to other magnet. Figure 8.12 represents the field pattern of horseshoe magnet. The field is almost uniform between the pole except near the edges. Uses of permanent magnets. There are many uses of permanent magnets, such as they are essential parts of DC motors, AC and DC electric generators. The permanent magnets are used in moving coil loudspeakers. They are very commonly used in door catchers. Magnetic strips are fitted to doors of refrigerators and freezers to keep the door closed tightly. They are commonly used to separate iron objects from different mixtures. Flour mills use permanent magnets to remove iron nails, etc. from the grain before grinding. In the medical field, they are used to remove iron splinters from the eye. A piece of permanent magnet is used to reset the iron pointer in a maximum and minimum thermometer. Applications of permanent magnets. Let us see how some of the following devices use permanent magnets. AC generator. When a coil is rotated between the poles of a permanent magnet, the magnetic field through the coil changes and an EMF is induced between the ends of the coil. On connecting these ends to an external circuit, an alternating current AC flows through the circuit. Electric motor is the reverse process of electric generator. When an AC is made to pass through the coil between the poles of a permanent magnet, it starts rotating. Moving coil loudspeaker. A voice coil attached to the cone of the speaker is slipped over one pole north to the radial permanent magnet as shown. From a microphone or some other sound signals in the varying AC current passes through the voice coil that is inserted in the gap of permanent magnet. This AC interacts with the magnetic field to generate a varying force that pushes and pulls on the voice coil and attached to the cone. The cone vibrates back and forth to produce sound in the air. Electromagnets. Electromagnets are also a kind of temporary magnets. An iron nail or a rod becomes a magnet when an electric current passes through a coil or a wire around it. It is called an electromagnet. When an electric current passes through the coil of wire, magnetic field is produced inside the coil that magnetizes the iron nail. As we have observed that the magnetic properties of an element are temporary, therefore iron objects remain a magnet as long as electric current passes through the coil. When the current is stopped, it no longer remains a magnet.